of implicit functions. All this while, in the videos we've made in the channel on calculus, the functions we have been dealing with are explicitly specified. But sometimes it's not always the case that the functions we deal with are explicitly specified. So you can have a situation where the relationship between x as the independent variable and y as the dependent variable, the relationship is implicit. So you cannot say that this one depends on the other one explicitly. So the two of them, coexist jointly, if you wish, or implicitly. And so in that case, we also need to find the derivative of the dependent variable with respect to the independent variable. Let me give an instance of what I mean. So assume we have a relationship of the form x squared y plus 2x squared y minus x is 0. Okay? So you see that this relationship is actually implicit. Who depends on what is not very clear here, because two of them are coexisting jointly. So this is an example of implicitly defined function. And so we need to differentiate such function with respect to y. Now to do this, we apply the rules we have learned. We have learned how to differentiate sum of two differentiable functions, and we have two functions here. Here we assume a and y is a function of x. So, and it's differentiable. X squared is also differentiable. So we have this first term is differentiable with respect to x. The second term is differentiable with respect to x. The third term is differentiable with respect to x. And of course, the zero function is a constant function. And so it is also differentiable with respect to x. Now, in each of the terms, for instance, here we have product of two differentiable functions. So we're going to apply the product rule to get the derivative of this first term. We also apply the product rule to get the derivative of the second term. Here, we're not going to apply the product rule because it's just but one term without any product. So when we deal with them, we apply two rules. First, the sum rule. Then, second, we apply the product rule here and here. And then we combine the result to get the final result of the derivative of the function with respect to x. So such a practice is what we mean by differentiating implicit functions. And so we take some examples. E.g., consider the function. It says if x raised to the power 3 plus y raised to the power 3 is equal to 7. Find the derivative of y with respect to x. If you observe closely here, you see that here we're saying that y is a function of x also, so this is implicitly defined. So we first differentiate here, we differentiate here, and so what is applicable here is only the sum rule. Okay. So we have that dx of x to the 3 plus y to the 3 is nothing but d with respect to x of 7. This is one way to go about it. Another way to look at it is that we can as well write this x to the 3 plus y to the 3 equals 7. We can write it as x to the 3 plus y to the power 3 minus 7 is equal to 0, and then we differentiate. Whether you take this to the side and differentiate, or you leave it as it is and differentiate, which is what I'm doing here, the result you're going to get will be the same. Okay, so this is nothing but the derivative of x raised to power 3 with respect to x, derivative of y raised to power 3 with respect to x. Of course, the right hand side is a constant, so the derivative is 0. If you differentiate x raised to power 3 with respect to x, we're going to get 3x raised to power 2. Then plus, here, if you differentiate y to the 3 with respect to x, you get 3y raised to power 2. However, y is also a function of x, and so we have to differentiate y now with respect to x. So here we are actually applying chain rule, because y is function of a function of x. And so we have 3y squared, then dy by dx. Okay, this is nothing but 0. At this point, our goal is to make dy dx the subject of the equation, which is not difficult to do. So if this is true, this means that 3y squared dy by dx is equal to minus 3x raised to power 2. And so we divide both sides by 3y to the 2, and that says dy by dx is equal to minus 3x squared divided by 3y squared. But this is nothing but x squared divided by y squared with a negative. So dy by dx is simply minus x squared divided by y squared. So this is the result.